All right, thanks a lot for the kind introduction. Indeed, my name is Ilmari Veijola. I'm from Siemens Industry Division and in more specific from a business unit called Cloud Application Solutions. Good afternoon, ladies and gentlemen. It's my pleasure to be here for the second consecutive time, and it's nice to see this event also alive and well today. And today, we're going to talk about the Siemens approach, how to counter the Industry 4.0 challenges. This is a concept that we call digital enterprise, and I'm going to start off with a short video that'll give you a good overview on what we're talking about today. All right, so as seen on the video, the Siemens Digital Enterprise Suite is our answer to the specific Industry 4.0 challenges that are presented to us due to the fourth industrial revolution. And these are speed, being able to get your products to the market at a faster pace, flexibility, being able to produce more and more customized products using mass production, without sacrificing quality, with the highest level of efficiency, and of course, you can never forget about security from a functional point of view as well as from the cybersecurity point of view. So our answer to this, it's not just about IoT or collecting data or data analytics, although that's a big part of it, I'll give you that, but it's more about the complete digitalization of the industrial value chain. We have a process that covers the process industries as well as the discrete industries. The same basic elements are there, although the tools and software might have some differences in them. So starting off from the product design, from planning your production to executing production and up until the finished product and services, the Siemens portfolio covers the entire value chain, and with the use of IoT, we can then connect the real-life production and product back to the very beginning of the value chain, meaning that we are able to generate a complete digital twin of the entire industrial value chain. And I'll give you an example about this. This is pretty high-flying stuff, so it's easier to start with a concrete example. We start off with a product digital twin. It doesn't mean we only have a 3D model of a product, but it's a complete virtual replicate of the product, meaning the mechanics, physics involved, the electronic circuits, and software involved. Take a car, for example. With the Siemens NX-CAD software, you're able to produce a rich product design, and bringing in the mechanics and physics aspect to this product with SimCenter, we are able to virtually simulate the mechanical stress to the car frame, for example. Similarly, we can simulate the engine heat distribution or aerodynamics of the car design, meaning that we're able to produce virtual prototypes. We don't have to build physical prototypes, or at least not that many anymore, meaning that we save a lot of time and resources in the product design phase. Siemens has complemented its portfolio with a lot of mergers and acquisitions lately. One example being Mentor Graphics. How it complements the product digital twin is bringing in the ability to simulate electrical systems of a product. Again, a car, for example. Same story with Polarium ALM. This company was bought by Siemens, and how they complement this product digital twin is the ability to simulate embedded software, which is basically present in every modern product nowadays. So we end up with a complete digital twin of the product, the car mechanics, electrics, software involved. Second thing, we need to validate our product specification with the virtual production environment. If you take a car manufacturing plant as an example, here is a scanned image of an existing car manufacturing plant. It's pretty easy and cost efficient to do images like this nowadays. And with a tool called Line Designer, you can basically draw on top of that scanned model and select your layout of the plant and the equipment involved. Next part in our portfolio is simulating the actual production process, meaning each phase in, for example, welding the car frame itself. We also have the tools to validate the complete workflow of an industrial facility, whether it's process manufacturing or discrete manufacturing, such as car manufacturing here. And really the great thing about these models is that all of the tools are integrated together in the one common data model in one common industrial value chain, meaning that out of the production digital twin, we are able to automatically generate automation code, PLC code, which is usually a very time-consuming and failure-prone process. So we are able to generate that code automatically, and even up to the extent that we can virtually commission an entire production line or an entire manufacturing plant before committing to any physical resources. This allows for very efficient change management. For example, you have to produce a new facelift of a car. You're able to validate everything in the virtual environment before committing into the real world. Of course, execution comes after this, but the commissioning times, testing times are a lot more faster and needing less resources when all the work has been already done in the virtual environment. So now we have the digital product twin as well as the digital production twin. And what IoT, and in our case it's MindSphere IoT operating system, what it brings to the picture is the ability to connect the real production environment and the real product, the car, into the cloud. We are able to collect data from those assets, analyze that data, and feed it back into the virtual digital twin environment. This also makes the business case usually a lot more interesting because the digital twin, it's not just used during the plant commissioning or design phase, but it's used throughout the life cycle of the entire facility, meaning that by connecting or closing the loop with the IoT systems, we can continuously enrich the digital twin model and keep it up to date throughout the whole life cycle. So, we feed analyzed data through IoT back to the different virtual environments, and that allows us to continuously improve our product as well as our production facility. Keeping in mind that all this happens within one framework, within a single collaboration platform, so that all the different engineering disciplines like electrical engineering, mechanical engineering, these are not siloed approaches anymore, but these parties are contributing towards the same complete digital twin model of the plant and keeping it up to date. So, a couple of words about our IoT operating system, which is called MindSphere. Maybe some of you have already bumped into the name at an airport or something. Basic idea is it's an industrial open IoT operating system consisting of 3 layers. First being Siemens bread and butter, connecting critical infrastructure assets into the cloud. We've developed a MindConnect agent that allows us not only to connect Siemens devices, but also virtually any third-party device or legacy device as well. There's a strong focus in Siemens development towards edge computing capabilities and fog computing capabilities in the future so that we can deploy the IoT analytics models into the field level as well, for example, for process industry purposes. Second level of the IoT stack is the operating system itself. Currently, we are running the version 3.0 in AWS infrastructure. It's also available for SAP cloud infrastructure. Azure version is coming up later on this year, and so on and so forth. We can run MindSphere virtually in any cloud infrastructure in the future. So there is an aspect of openness to that as well. And finally, getting the value out of the data, analyzing the data with different applications and services. We've created an open application environment consisting of different Mind apps, meaning that basically any third party can join in, develop their application on or service, and deploy it through the MindSphere App Store for the global MindSphere users to then utilize. This allows the IoT users not to be vendor locked to any Siemens system. They can utilize whatever hardware components they want. They can run this operating system in virtually any cloud infrastructure, and they can freely select analytics applications from the marketplace, not just locked into Siemens services and analytics, although our business units will be contributing a lot into the Mind application environment. That's the basic idea of MindSphere IoT operating system. So, finally coming to actually solving the Industry 4.0 challenges, here are some figures that we were able to achieve at a Maserati automotive plant in Italy. Basically implementing these tools and conducting the digital transformation of the organization, meaning training the people, getting them to use these tools, we were able to significantly reduce the development time of their cars by 30%. In the modernized plant, it's possible to produce 70,000 different combinations of the Maserati vehicle in a single production line, and the output, as of compared before the modernization, is threefold. At this point, usually a question I get asked a lot is that, all right, I'm not Maserati or I'm not Siemens, I'm a small or medium-sized enterprise from Finland. How does this apply to me? Can these tools be utilized by the SMEs? And actually the nice thing about software applications and cloud itself is that the solutions are really scalable. We can start small, we can find a specific use case, and with very low effort at first, start utilizing these tools so that we can produce actual business value out of it. Here's one example that we've done in Finland. It's a food and beverage plant, packaging line, a tray line, and the use case was that at the plant there was a 4-day plant shutdown coming up, and they needed to modernize this packaging machine and be sure that after those 4-day shutdown it'll work. So we decided to carry out a virtual commissioning before that shutdown. We built a model of the tray line system. We built a virtual model of the automation system, and we were able to virtually commission the entire tray line before the actual shutdown took place. Clear benefits to the customer. More than 10 PLC code errors, failures were found during the virtual commissioning. We were able to correct all these before the actual plant stoppage at the plant took place. They were also able to validate a new operation method of that specific tray line. I'm not exactly sure about the details, but it allowed them to simultaneously fill the trays or something like that, and using that kind of validation method, they were able to increase the productivity of this packaging line. And also, what was really the customer target was on-time commissioning of the packaging line system. So, very little effort. It took us 2 days to build a model of the automation system and of the tray line. low effort, small project for a medium-sized corporation and a clear benefit to the customer in that sense. So the Siemens message is based on this approach that you should all realize your digital transformation better sooner than later and make the future yours. That's it from my side. Thanks a lot to everyone, and feel free to come and talk to me and my colleagues at the Siemens stand later on. Thank you.